In this section, we build our first neural network for tabular data with TensorFlow 2.0. In this video, we will talk about the pipeline for building a neural network. So there are a number of steps that are required in building a pipeline for a neural network. So it is basically a 6-step process. In the first step, you will load the basic libraries you require for data collection, manipulation, and passing it to the neural network. In the second step is to load the data from different sources like CSV, JSON, or maybe images or text. And the third is like cleaning data. Most of the real world data is not clean, hence you have to clean the data before using. And then you do exploratory data analysis of the data to find out interesting patterns in the data. And finally, you do data modeling, that is finding the relationship between the input features and the output labels. And finally, then you evaluate your model against the test set. So that was just a brief about all the 6 steps. Let's go deep into step 1. So step 1 is loading libraries. So whenever you're working with any data science problem, you need 3 to 4 libraries that are very basic, and in every problem, like NumPy. NumPy stands for numerical Python, and it is for faster array computation, and it is used to actually achieve the results faster. And then we use TensorFlow for building deep learning models. And then we have pandas for loading data, and they provide a very good data structure called data frame. And when a data is in our data frame, we can actually do a lot of analysis on a data very easily using 1 or 2 commands. And then we have Matplotlib to actually plot the data for effective visualizations. Step 2 of the pipeline is loading data. So as I said, that loading the data can be either a CSV file or maybe an image or maybe text. So for loading CSV, pandas provide a function called readCSV function, and it returns the data frame, which is very easy to work on, and you can apply a number of various data manipulations on the data frame to achieve great insights about the data. Another word of caution for the images: sometimes we have a very large data set, say about 5 to 6 GB, but the RAM of computer is only 2 GB to 4 GB. So in that case, it is not possible to load the entire images in the memory at one go. So for that, we use generators. So what does generator does is it does an in-time loading of the images. That is when the images are to be processed, then only it is loaded, and when the processing is over, the images are deleted from the memory. So moving on to step 3 is the cleaning of data, which is a very important step because most of the real world data is not clean. Hence, this step is the most time consuming step you will ever face in a data science pipeline. What are the operations that you can actually do in the cleaning phase? So you can detect duplicate rows or columns and delete them because they do not add anything to your modeling. Instead, they just contribute to overfitting of your data. Then you can detect the null rows and columns and fix them either by mean, median, or mode. As you observe that a computer understands a language in 0 or 1, so it doesn't know what null is. So you have to take care that you should not pass null values to a neural network at the training phase. Also, you can detect outliers that may affect the data distribution, and you can change the data type of a column, like from object to timestamp, or maybe from string to int, and so on. The step 4 of the pipeline is exploratory data analysis. And this is an important step to get insights about the data, to know about the hidden patterns in the data. And in this step, we actually get to know the most important features about the data just by analyzing the features visually. Also, we get the correlation between the various features and patterns and manipulate highly correlated features. Also, we can drop less important features which may not contribute as much to the model and may not be good for the distribution. So in modeling step, what we do is we try to find mathematical relation between the input features and the output labels. So we create a neural network. So when we create a neural network, we create it so as to perform 3 tasks: forward propagation, compute loss, and then back propagate to optimize the weights of the neural network. We will talk later in this section about forward propagation or loss function or back propagation, but at this moment of time, you just have to analyze that a neural network has three operations: forward prop, in which the values are computed from left to right, then a loss function, at which we actually get to know how much are the values far away from our actual value, and then we have back propagate to actually optimize our weights so that we go close towards our goal. And finally, the step 6 is evaluating your model. So in this step, firstly, you actually save your model for future use, and then you evaluate a model against the test set to get an idea of how well the model is generalizing to the data it has never seen. If the performance on the test set is not satisfactory, then you might need to retrain the model, or else it is satisfactory, you can deploy it to production.